What a wonderful day it is when Tesla drops new demos with their Tesla bot Optimus. Today we have Dr. Scott Walter, Tesla bot expert and two-time industrial robot company founder here with us. We're going to review the 44-second video that they just dropped. We'll also watch a slowed-down version to count how many bots are in the lab. And we'll review what Milan Kovac, top Tesla bot engineer, said about what's next. Scott has found a number of very interesting nuggets. Welcome, Scott. Thank you for joining me.
Hello, Herbert. As you can see, I'm on the road, and of course, that's what I get for wearing my Tesla bot T-shirt on a Saturday night. So it seems like they always drop them early in the morning, don't they?
You're not in great visual there, but that's okay. It's what matters is what you're going to say and tell us what we're seeing here. So let's watch the video. This morning, Tesla dropped this video, and I'm going to take out the music, but you go ahead and speak to it. What are we watching here?
Okay, as I mentioned there, it's fully autonomous, and it's doing something that maybe we had hints to a few months ago when they showed Optimus for the teleoperation with the folding the T-shirt. There were some battery cells in the background, and I was like, not quite sure what they'd be doing with them, but this is in line with what Elon said about them doing some work in the lab and then starting to do it down on the floor. Because as we had mentioned earlier, it's something that could very easily mock up in the lab without having to actually go to the floor. And that was just like the end of the line pick and place from their battery line. And so we're seeing that it's, the conveyor is ironically being fed manually by a human to simulate what the conveyor would look like. And then the bot is learning to do the picking and placing and put it properly into the tray, as well as making corrections for any errors. So there's error detection in there. And then here is it actually being used in one of the production lines. Now, it is a little bit mysterious. As some people have pointed out, there is another pick and place mechanism in there, which is a very simple, kind of almost 2 degree of freedom mechanism for picking the cells off the line and putting them on that exit conveyor, and then to have the bot doing that. And it certainly does beg the question of like, well, wait a minute, why don't you just use the same kind of mechanism at the end there? And I'm not sure what the answer to that is, except that maybe the way it's configured right now, they haven't bothered to automate that because things are still in development, and it may actually be a manual unload that's going on there. There could be several reasons for that, and that is, it may be that it's a very slow process that doesn't require automation, or it may be like a reject line or something like that, where they're just trying to pull these that have failed a test or something like that to get removed out of it. And the mechanism that's inside there is in kind of an area that's a bit more enclosed, where you don't want a person to be grabbing directly off the line. So you have a mechanism that just puts it on that output chute that then a human can go in and take it out. So as a replacement or as a plug-in to an existing system. So again, I think that's a low-speed operation, because I'm not sure what happens to that tray when it's done. It just sits there on the table. There's like no conveyor or something like that, so it must get picked up and moved somewhere else. So if you're producing, millions of batteries a year, and that is where they're exiting from, that's not what I would expect. I would expect to see a different line. So I suspect what that could be is that after the batteries have gone through testing, there's like, oh, they're getting rejected, they're doing another round of testing, and then they're just being pulled off.
Yeah, we'll have to see whether or not that's the actual task.
Yes.
So a few more things we're going to cover here. We got Milan Kovac's tweet. We've got a slowed down version so you can show some of the gems that you discovered. And then Elon just tweeted out just a few minutes ago, right, about the 12 degrees of freedom. Do you want to speak to that briefly?
Well, yeah, it's, look at it exactly, because I literally just saw it before coming on. I think he said 22 degree of freedom
22
hands.
Yeah.
And I think, hands plural might mean 22 degrees of freedom over both hands. Right now, they have, I think, 11 degrees of freedom per hand, sort of depending upon how you look at it. There's really, there's the movement of the knuckles. So it may be that they're either adding some knuckles to get a little bit more in there, or they may be doing this hand splay that we sort of talked about before. So it sounds like they're coming up with a hand that's going to be maybe a lot more human-like and in the sense of its dexterity and its capabilities. Now, I think we've talked about this in the past. Depending upon the application you're doing, you don't necessarily need the best hands. So there may be some applications where you want to have a very advanced hand to do it because of the dexterity that's required, and others where, as we can see in this case, the Optimus hand is perfectly good at being able to do the task that's in front of it right now. So there's no need to say over-engineer something for certain solutions. But clearly, if
Yeah.
you need something that's very general purpose, then you probably would want to have something with higher degrees of freedom hands. And if I read it, so the new Optimus hand, oh my goodness, the new Optimus hand later this year. So he's talking about 20 degrees of freedom in one hand.
Yeah.
Okay, that means full knuckles is what they're going to have in there. They probably are going to definitely be able to have the hands move back and forth like this. And then who knows, maybe a little bit additional degrees of freedom in the thumb, because the one thing about the human hand is that our palm is not stiff. It's able to kind of crunch in. I'm wondering if they're going to be attempting to add even another degree of freedom there. And that would be
Nice.
interesting to see how they be coming up with mechanisms. So I'm going to have to sit down with a piece of paper and do some of my homework to see how they kind of get there. So again, right now they have sort of 11 degrees of freedom, if I recall, but only 6 motors. So the extra degrees of freedom are basically meaning movements in the knuckles, though they're kind of required to move together. It's one actuator moving both of my knuckles, or all 3 of my knuckles right now, if you think about it. So they might be adding some more knuckles, and again, this movement that way. So this movement, you're basically adding like 4 more degrees of freedom. Oh, so that takes us from 11 to 15. So where are the others coming from? They must be adding a knuckle.
Nice. Yeah, interesting thing, because I think what that matters is, do we think that they're design locked? If they're already making 12 plus bots today, when do they go? But if they're going to design a new hand, maybe that will take them a little bit longer. Let's go right to Milan Kovac. He's the lead engineer of the AI team for the bot team. And he said this: over the past couple of months, our awesome manufacturing team has built more bots for us to work on and collect AI data from. We've trained and deployed a neural net, allowing Optimus to start doing useful tasks, such as picking up battery cells coming down a conveyor and precisely inserting them into a tray. This neural net is running entirely end-to-end, meaning that it only consumes video coming from the bot's 2D cameras, as well as onboard proprioceptive sensors, and produces joint control sequences directly. It runs entirely on the bot's embedded FSD computer, powered by the onboard battery. It is designed such that a single neural net can perform multiple tasks as we add more diverse data to the training process. This is the big section here. While not being perfect yet and still a little slow, we're seeing increasingly high success rates with less frequent misses. We're also training Optimus to recover from failure cases and are seeing spontaneous corrections happen. Deployed a couple bots in one of our factories already, where they're being tested daily at the real workstations and continuously improving. Optimus also now regularly takes long walks across the office without failing. And then this is the big part, right? He says this is what they need to do. They need to work on to make it move faster. They needed to deal with more adverse terrains, all without sacrificing the human-like nature of it. We're also focusing on repeatability across the fleet. When you train one, can the others? Because they need to be able to train the neural net to deal with dynamic calibration and small bot-to-bot variants.
Yes.
Anything you want to point out here in this entire post?
Okay, so the first thing when I saw the video, I had a bunch of thoughts, and I know, well, the first thing to do every time these bot videos drop, wait an hour or two, and Milan will repost it, usually with some comments about it. So his comments kind of fit in with what I was observing. One is that, well, okay, it's interesting what we're seeing here, but it still seems pretty slow. The picking and placing is not super fast. The bot doesn't seem to be walking any faster, and he's addressed those issues. And so they're not really focusing that much on making the bot faster. It's more on making it reliable, because we've talked about that for useful work. It's like, just because it's really quick, it could do one task really, really fast. If it can't do it reliably, it keeps on doing failures, then speed is not that important. So the first thing is getting the training, getting the reliability, and then they'll start working on the speed over time. So that's important. The other thing is, he mentioned that they deployed several of their bots, not one, in different workstations. I think they've intentionally shown us the most boring application right now. They're probably doing some others that they just don't want to reveal at this point. So I get a feeling there's a certain amount of sandbagging, because while this is the most interesting thing that comes out of this is like the number of bots that we're able to count here, which seems like there might be about a dozen. And he talked about the manufacturing team being able to give them, more bots to be able to training. But as far as what we've seen Optimus do before, being able to pick up blocks and move them around, it seems very similar. So it's not like it's this order of magnitude change. The big difference is that they're putting it into more manufacturing scenarios, that they're starting to get more reliability out of it, and that they're pretty confident they'll be able to scale that. So again, I don't think they're really showing us the whole picture. We're just getting a glimpse
Yeah.
of it. But the other thing is that they're comfortable enough to have it walk around for a long time in the office space without it falling or failing or anything else. So that tells us that they have a lot more confidence in that. And once you have that certain degree of confidence that everything is going right, you can start to improve the speed, which is probably what they're going to do next.
Yeah, and then the part about that they want to make sure that I'm trying to find it now. Small bot to bot variance, right here,
Yes,
focusing on
right.
repeatability across the fleet. So that means if one bot learns it, can the other bot now do it? And it's just a
Yes,
simple transfer. But
yes.
they're different, right? They're
Yeah,
the
they're
same
different. And I think
design,
what you want to do is go
slight.
almost what
Yeah.
he said at the very beginning. He talked about the
Hmm.
2D sensors, and we did have a nice view of what the robot's point of view is. And it has a couple of cameras, and with the two cameras, it can create that three-dimensional scene that it needs to understand what's going on. And he talked about that in proprioception. So they're taking that along with the robot's proprioception for the neural net. And proprioception means that the bot has to be aware of where it is in space. It's kind of this idea of a calibration. And that when you go from one bot to another, they have to figure out how to relate the proprioception that one may have been trained with to what the other one is seeing at the same time, because they may not be identical copies of one another. So that's more of a calibration issue that they'll be able to take care of to make sure they really can move it from one to another. Because unless the bots have to be absolutely identical to go from one to another without some sort of calibration step. And that's
Yeah.
already a solved problem as far as industrial robots are concerned, because it's the same problem. Is we teach industrial robots to do a particular program on one bot, and then we move it over to an identical bot in an identical situation, and it won't work the same because the bot is not constructed exactly the same. So they go through this calibration phase where they get something that's called a signature file, and the signature file is able to adapt the differences between the two. So that's sort of what he was hinting about when he talked about the proprioception and then being able to move from one to the next.
Small bot to bot variances. That's just,
Yes,
once they figure this out, then they can go ahead and
and
decide to make
the
1,000.
thing to
Right now, still
yeah,
trying to do just 12.
and the thing to remember is these bots, their signatures drift over time as well, after
Mhm.
wear and tear and everything else. So they may start performing a little bit different depending upon
Mhm.
the scenario that they're in. So they have to constantly even be able to update for themselves. And we also have to do it. I mean, we have to understand where our bodies are constantly to be able to do things.
Mhm.
And we have muscle atrophy and everything else that it changes, and we're constantly updating because we're able to
Mhm.
calibrate where our hand really is in space just by kind of looking at it and saying, oh, okay, that's what that feeling of my arm in that configuration means right now. It means my hand is in that configuration, whereas before it meant something a little bit different.
Okay, let's take a look at a slowed down version. Humanoid Hub said, I spotted 12 Optimus bots in this short clip, excluding the one that's walking around. Each robot is being operated by a human teller operator for data collection. It's in the lab, they're testing it, and it's a great little clip because you're watching it, kind of very slowed down. And let me pause it here, but you can see that yeah, they're all. What's really cool is they're all Gen 2. So the last time we saw the lab, we saw that there was a number of Gen 1s there too. So this looks like they're all
Yes,
Gen 2 at this point, Scott.
exactly. I did not see any Gen 1s in there. And I think the funny thing is the teleoperators, I'm not sure if they're humans or if they're robots themselves. I mean, it's
Ah,
the
come
way they're
on.
kind of standing there with their hands out there, you kind of
Well,
wonder
slow
for a
down.
second.
It's slowed down. Yeah, yeah.
No,
It's absolutely
yeah,
slowed down.
everyone that's dressed in black there, I think those are humans.
Yeah, they
And
are. They are.
yes,
Yeah.
and we're
But
seeing they're doing tasks other than sorting batteries there.
right. So let's take a look at that next because it is kind of odd. But Tesla Trillion said, anyone notice Tesla Optimus is doing work at the same speed as this? Oh, this is a different thing before we get there. Specialized
Right.
robot on the right. So let's take a look at that since we're here now. But basically, I mean, yeah, they might have slowed down the battery, but they are looking like they're every time they're putting one. They sped up the Optimus, but they must have slowed down this. I mean,
Oh,
this thing
yeah,
I'm
yeah.
sure can
Well,
work
well, see,
faster.
it's all being right now. Everything is being paced by the actual circular conveyor that you see there. So that's what's kind of controlling everything is the rate that
Mhm.
that advances. So you get that mechanism which is picking and placing it off there, and that thing is designed to whatever that rate is supposed to be. And that's
Mhm.
not I don't think that's an off-the-shelf robot. It's probably a very simple mechanism you can put. Some people would argue whether that is actually a robot or not. It may not have quite enough degrees of freedom, but it is a specialized piece of equipment just to be able to pick and place those things, and it's more or less whatever the rate is that everything is going around there. And then, of course,
Yeah.
Optimus is then able to keep up with that. And that output buffer, or the output conveyor you see there, is a little bit of a buffer. So potentially it could collect a half dozen or so if Optimus, let's say, picks up the tray and moves it somewhere else, it has to come back. And then it could go back and start picking them off to make sure it doesn't back up too much. So they have some built-in buffers there to make sure that you don't have to be completely synced with the line and be able to catch up if for some reason there's a slowdown. And then the other thing, normally what you would do in a situation like that is you might have another robot like a Scara robot, which is really fast, actually be able to pick up not one battery, but maybe a row of batteries at a time and just be able to pick them up with a specialized gripper that's able to do it if you were stuffing them through there at a really high rate. But as we can see, the rate is pretty slow, and it is so slow that you could have a human being able to keep up very easily for 8 hours a day. But that's a rather boring task that we can see.
Yeah, but another thing, well, the point that you made earlier with me was that why did they show you this particular task, battery sorting, when you already got an industrial robot? Are they, one, trying to say, hey, we're going to replace that industrial robot? Or B, this is a misdirect. They're saying, hey, we're just showing you this task, but we got others, so we're not going to show you.
Yeah, so it's not so much that it's an industrial robot. It's a mechanism that's in there that's sort of part of that whole production line. And you're not going to replace that thing there, because the point of that thing is to pull it off and put it on that output conveyor, that little spur that comes kind of out there. That's how it exits that cell. Because if you look at that cell, there's a lot of plexiglass around there, right? So you really can't get in there to do that task. And so that's an enclosure that they don't want anyone to be able to get into. And I'm not sure, it's not necessarily hermetically sealed, because I'm sure there's some air going through there, but in one way they want to make sure contaminants aren't getting in there. And it's also to kind of block people from being able to poke their hands in and around there. And so that's how everything is exiting. And then you just go over and then pull it off that line into there. So that may have been designed as a manual station all along, or one of those things, excuse the pun, kicking the can down the road kind of thing, that they may be thinking of, well, at some point we're going to automate that, but we haven't figured out how, because we're not even sure what the whole line is going to look like. So let's not automate something that later on we're going to tear out because we've changed everything. And it can be done right now with a manual process. And then they probably said, hey, wait a minute, if we were to get a manual process that's really simple, let's see how easily we can automate it with this plug-in automation tool called Optimus. We just drop it right on in there. And without any rechange the configuration, nothing else. Just like, and who knows, this might be an operation that runs like 20 minutes every hour. So that means, Optimus, just go over there and unload those, will you, right now? And then go off somewhere else. Because it's possible these batteries are going through like some sort of testing procedure somewhere where they're being charged and discharged, everything else to test their quality. And then once that's done, suddenly, boom, you get this big bank of batteries coming out that now have to be put in maybe the reject bin or something like that. And then someone has to come over and do it. And then when they're not doing it, they're doing a different task. So there could be a lot of reasons why you don't have hard automation there.
Okay, makes sense. Thank you for explaining that. So let's take a look at the other tasks that they're being trained for in the lab. Humanoid Hubs pointed this out. Video shows teleoperated data collection for laundry sorting, organizing a shelf, and battery cell sorting. So when they slowed down that video of them going through that, you can see this is a basket with clothes, and they're sorting it, being teleoperated, right? Then, then you got a cubby. And we know that from the Sanctuary CEO, he said he ran a robotics company in the past, and that was what they did, was, putting pick and place into cubbies in a cupboard like this. And this is interesting. There's like a different, there's some sort of a bottle here, shampoo bottle almost, and some sort of, some sort of other material at the top here, a jar. So it looks like that. But why are they doing, it seems like residential tasks.
Oh, yeah. I mean, those are things weird. I see in the factory floor all the time. Baskets of laundry that needs to be folded and things that need to be put in cubbyholes. Yes, it's a good question, Herbert. It doesn't look very industrial to me. It looks like they are trying to solve two problems at the same time. Residential as well as factory.
Yeah. Yeah, my guess is that they're still in the hardware design stage. And remember when they did the folding of the clothes that was being toddler operated? They said the reason they were doing that was they wanted to make sure the fingers and the hands, if it can fold clothes, then it's design locked. And it looks like they're going to go with the 22 degrees of freedom, but they just want to test it. So it's almost like, are you training it to be able to do that task, or are you training, or are you just doing it just to see if it can do the task? Because if it can do that task, it could do almost anything.
Right,
That could be one
right.
reason.
And well, yeah, and I think the other thing is just think of it as like cross training. Most athletes, they improve their performance by not just focusing on their sport, by also doing other things that complement it. So, I mean, even as cross country runners, we were encouraged to lift weights. Okay. What's weights got to do with running? Well, it can help develop certain muscle groups a bit better and make sure you have kind of the strength that you need there. So it's sort of the same thing is as it improves these skills that may seem to have nothing to do with the factory floor, it starts to develop techniques that maybe will be applicable and makes it more useful. So that there's nothing wrong with them trying to do different tasks because because he even mentioned in there, I think it was Milan or maybe it was Julian that mentioned something about like an emergent behavior that are starting to come through as far as error correction and everything else. And the
Oh
best way to
yeah.
get that is do a lot of cross training.
I just lost. I accidentally deleted the Julian uh, uh, post. Okay.
Oh, okay.
Oh man.
Yeah.
So I wanted to cover that. Hold on. So while we're doing that, let's just review a few more things here. You've got Tesla Economics just reminded us what is it that Elon said on the Q1 2024 earnings call. He said, we do think we'll have Optimus in limited production in the actual factory itself doing useful tasks before the end of this year. So when he said that useful tasks before the end of this year, we thought that, okay, right now it's being trained in the lab. It'll be trained in the factory next year, at the end of this year. But it turns out they already did it now. They already
Mhm.
brought the Optimus there. But if you're saying doing useful tasks, then that means it's actually, actually physically there and actually being hired by the factory. And that's what Milan said. By the end of this year, it'll be able to do useful tasks. And I think we'll be able to sell it externally by the end of next year. This is what Milan Kovac said. Further work is ongoing to make it move faster, deal with more adverse terrains, um, repeatability across the fleet, training to deal with dynamic calibration and small bot-to-bot variants. Sounds like these are like, it sounds doable, right? If these things are doable, how long will it take, Scott? Because then that's how we get to scale. I've been talking to a few people and they were saying to me, you don't realize how long it's going to take to make them go faster while maintaining quality. In the meantime, I've been talking to you and I have been interviewing a lot of bot CEOs, vendor CEOs, and a couple of them basically said speeding it up is not going to be the problem. The most important thing is teaching autonomy and then finalizing the hardware. But if we wanted to focus on speed, we just turn it on. What's your nuanced answer to that question?
Yes, my feeling is that if you turn it on, you're just going to probably have a lot of errors coming quickly if it already doesn't really understand its full motor control. And that comes with more and more training. And as you see it gets more and more precision, you can start to speed it up a little bit. So there could be maybe 3, 4 different reasons why it's not very fast. Um, One of them could be that mechanically there's some issue, that the motors just aren't able to put out enough torque or something like that. In other words, you didn't design it right. And that'll say it's not the case. The reason it's not the case because they've gone through and done the analysis. They know what the size of the motors need to be, et cetera, to be able to do that. And it's very easy to do something like that. So when you design a car and you say, I need to have a car go from 0 to 60 in 6 seconds, and you know kind of what the mass of the car is going to be and everything else, you can figure out what size motor do I need to put in that car so it can do that. And that's the same thing with the movements that they've done. They've studied all the different movements. They've got an idea what the sizing of the motors have to be. So I don't think it's a mechanical issue. The other could be that, well, maybe all they have to do is give it a bit more power. Okay, so they run a bit more juice through it, and that's one way to make it go faster. But they might be saying, well, we really don't want to do that right now because we want to stay within our energy budget. So we don't want to be having twice the power consumption. We want to find another way to be able to do it without just going ahead and saying just push the foot down on the pedal. So that means the third way of doing it is just more of a software issue that they're going to be going through and learning how we can optimize it, getting it better. And I tend to be more towards that end of that. It's a software issue. And part of it has also been backed up because has also been mentioned by Brett and others to say that we're not concerned about the speed right now. That will be sped up in software. So they're pretty confident that their hardware has it. They're pretty sure that it's well within the power requirements that they're going to have. It's just a question of having the software be able to do it and maintain stability and accuracy.
Yeah. All right. I found what Julian Ibarra said. He's also a part of the Tesla bot team. And he said this: we've improved the reliability of our learned behaviors across our fleet. Right. So when you got a fleet of 12 or a lot more, when one learns it, can the others get it? The reliability. And decided to bring a few robots in the factory to perform a really useful task: sort batteries around. The autonomous behavior you see below can run on the robot for hours until we need to recharge the battery. So we don't know yet how long these Tesla bots can last for. We've heard, right, Scott? We've heard other bot vendors say that they can work for 4 hours. They need to be charged for about an hour. But you would assume that Tesla, because of their battery expertise, they're going to be able to do this even longer.
Yes, I would think. And the other thing about this is, once again, Julian is corroborating what we heard from Milan, that several of the bots down to the floor in real factory situations. I like this because he did talk about that they're working on reliability. That's the important thing. So they need to make sure it's able to do it continuously for hours on end without any mistakes and on a single charge without having to recharge. And we've already sort of forecasted they should be able to do that. In theory, they can go 4 hours at about 500 watts. And maybe that's about what their energy budget is right now. And if you can go 4 hours without needing a charge, that will be okay because you're taking breaks anyways on the factory floor. So if you just fit it into the normal break schedules, you'll be able to top off your batteries and keep going through and probably make it through an 8-hour day.
Nice. All right, another email post from Elon just a few days ago. He said this: I think the ratio will be at least 2 bots for every human, maybe 3 or 4, as there will be in many in industry producing goods and services, often for other robots in the supply chain. So this sounds like he's thinking that there's going to be 2 billion, 2 times every human. That's going to be billions and billions and billions of humans.
Yes, if you're looking at a population of 8 billion, you're looking at 32 billion bots. That's a lot of bots.
It's crazy. He's basically describing a utopian future where everything could be made by basically 100% bots, both bots and the industrial robots. And then you've got it. Everything's going to be automated. Everything will be cheaper, and so forth. This is funny. Smokeaway had this. I think it's hilarious. At first I laugh, and then you go, actually, it kind of makes sense, doesn't it? I don't think they're going to use wireless.
Yeah, maybe there's a whole reason to have something like that to protect Optimus from the weather while it's waiting for you to come to the supercharger.
No. That's just funny. Although it looks so great, doesn't it? I don't think so. I'm not one who thinks that they're going to have a bot there to plug it in. I think they're going to, obviously upgrade it. Doesn't make sense to have a humanoid bot out in the elements and people can, make fun of it and do whatever you want to do with it. Doesn't make sense. Okay. So basically, any other comments? And when you see it, right? Only 2D cameras, hand tactile, force. It balances on its legs while the network drives the entire upper body. It sees something slightly different, but precise movements are required with little margins during insertions. That's why they want to show this, right? Because it needs to be very precisely putting it in place. The other demos we've seen of other humanoid bots, they weren't like this. They were like grab and move and grab and move. This one is very precise of where it's placing it. That's one of their pointing out, right?
So yes, and I guess I wonder if the job description for working with this Optimus was you needed to be, a croupier on the craps tables that you see for gambling, where you're just kind of pushing the little rake back and forth, because that seems to be a pretty easy job, just picking them up all day and pushing them in there to feed the robot. And I wonder if dental's included in that job.
Great. Oh, we love it whenever there's a new drop. Thank you for your knowledge and the nuggets you dropped as well too, Scott. Fantastic. Thanks for teaching us. Thank you,
Yeah,
everybody.
and I guess
See you
the
soon.
last thing that I could say is that, from what Milan was talking about there in the operations that they're doing, it looks like they've decided to put Optimus through a battery of tests.
Very good. Love it, Scott. Love you. See you guys. Bye, everybody.